Are you ready to master simultaneous equations once and for all? Whether you're preparing for an exam, brushing up on algebra, or just love solving puzzles, this tutorial is for you. In this video, I'll break down the most effective methods to solve simultaneous equations, step by step, from basics to advanced tips. We'll explore everything from the graphical method to powerful algebraic techniques like elimination, substitution, and comparison. By the end of this session, you'll not only understand how to solve these equations, but also know which method works best for you. So grab your notebook, stay tuned, and let's dive into the exciting world of solving simultaneous equations. Understanding simultaneous equations. In this video, we will explore various methods of solving simultaneous equations in a simplified manner. Learning objectives. 1. Understanding solutions to systems of equations. The solutions to a system of two linear equations in two variables correspond to the points of intersection of their graphs, whether the graphs are straight lines or curves. 2. Solving simultaneous equations algebraically. We will solve simultaneous equations involving two linear equations in two variables using different algebraic approaches. What are simultaneous equations? Simultaneous equations are two or more algebraic equations that are solved together to find the values of the unknown variables. For linear simultaneous equations with two variables, we can solve them using the following methods. 1. Graphical method. 2. Elimination method. 3. Substitution method. 4. Comparison method. Graphical method. The solution to simultaneous equations corresponds to the point of intersection of their graphs. For example, first equation, x plus y equals 2. Second equation, y equals x plus 1. The solution to this system is x equals 0.5 and y equals 1.5. This solution represents the point of intersection of the graphs of these two equations. Elimination method. In the elimination method, one variable is eliminated by adding or subtracting the equations, leaving an equation with only one variable. Steps. 1. Ensure one variable has the same coefficient in both equations. 2. If the coefficients of a variable have the same sign, subtract the equations. 3. If the coefficients have different signs, add the equations. 4. Solve the resulting single variable equation. Example 1. Solve the equations. First equation, 5x plus 2y equals 24. Second equation, 3x plus 2y equals 16. Both equations have the same coefficient for y, which is positive 2. Subtract the second equation from the first. 5x minus 3x equals 24 minus 16. This simplifies to 2x equals 8. Solve for x. Divide both sides by 2. X equals 4. Substitute x equals 4 into the first equation. 5 times 4 plus 2y equals 24. Simplify. 20 plus 2y equals 24. Subtract 20 from both sides. 2y equals 4. Divide both sides by 2. Y equals 2. Solution. X equals 4 and y equals 2. Example 2. Solve the equations. First equation, 2x minus 2y equals negative 6. Second equation, x plus 2y equals 3. Y has opposite coefficients in the equations, negative 2 and positive 2. Add the equations. 2x plus x equals negative 6 plus 3. Simplify. 3x equals negative 3. Solve for x. Divide both sides by 3. X equals negative 1. Substitute x equals negative 1 into the first equation. 2 times negative 1 minus 2y equals negative 6. Simplify. Negative 2 minus 2y equals negative 6. Add 2 to both sides. Negative 2y equals negative 4. Divide both sides by negative 2. Y equals 2. Solution. X equals negative 1 and y equals 2. Substitution method. As the name suggests, This method involves solving one equation for one variable and substituting that result into the other equation. Steps: 1. Make one variable the subject of the equation. 2. Substitute this expression into the other equation. 3. Solve the resulting equation for the remaining variable. 4. Substitute the value back to find the other variable. Example: solve the equations. First equation, x plus 4y equals 6. Second equation, x plus 3y equals 4. From the first equation, solve for x. X equals 6 minus 4y. Substitute x equals 6 minus 4y into the second equation. 6 minus 4y plus 3y equals 4. Simplify. 6 minus y equals 4. Subtract 6 from both sides. Negative y equals negative 2. Divide both sides by negative 1. Y equals 2. Substitute y equals 2 into x equals 6 minus 4y. X equals 6 minus 4 times 2. Simplify. X equals 6 minus 8. X equals negative 2. Solution: x equals negative 2 and y equals 2. Comparison method. This method avoids complex fractions by equating expressions for the same variable from both equations. Steps: 1. Solve both equations for the same variable, e.g., x or y. 2. Equate the two expressions. 3. Solve the resulting equation. 4. Substitute the value into one of the original equations to find the other variable. Example: solve the equations. First equation, 5x plus 2y equals 24. Second equation, 3x plus 2y equals 16. From the first equation, solve for 2y. 2y equals 24 minus 5x. From the second equation, solve for 2y. 2y equals 16 minus 3x. Equate the two expressions for 2y. 24 minus 5x equals 16 minus 3x. Simplify. Subtract 16 from both sides. 8 minus 5x equals negative 3x. Add 5x to both sides. 8 equals 2x. Divide both sides by 2. X equals 4. Substitute x equals 4 into 2y equals 24 minus 5x. 2y equals 24 minus 5 times 4. Simplify. 2y equals 24 minus 20. 2y equals 4. Divide both sides by 2. Y equals 2. Solution: x equals 4 and y equals 2. Conclusion: practice these methods with additional problems to reinforce your understanding. Remember, each method is valid. Choose the one that feels most comfortable for you. If you have questions, comment below or message me. Don't forget to like, share, and subscribe for more tutorials like this. Thanks for watching, and see you in the next video.